Baa-king news. Italian island overrun by adorable goats seeks new homes. An idyllic Italian island paradise is facing a most unusual problem. Too many goats. Circuitry, a small island nestled off the coast of Sicily, has become overrun with these charming but nibble-happy creatures. The local human population of 100 is vastly outnumbered by a herd of over 600 goats. The island's tranquility has been disrupted by these prolific grazers. Originally introduced for breeding purposes, the goats have multiplied far beyond expectations. They've descended from the cliffs and mountains, munching their way into gardens, munching on crops, and even occasionally wandering into homes. Faced with this bleeding abundance, the resourceful Mayor Riccardo Gullo has hatched a brilliant plan: the Great Goat Giveaway. This novel initiative offers these friendly goats, free of charge, to anyone willing to give them a loving home. The news has bleated across the globe, with animal lovers and aspiring goat herders expressing a barrage of interest. While the initial plan was to find homes for these cuddly caprines within Italy, the overwhelming international response may lead to a broader adoption program. However, there's more to welcoming a goat into your life than just a cute face and a penchant for greenery. These animals require proper care, including food, shelter, and veterinary attention. So, potential adopters should be prepared to offer a responsible and loving forever home. This heartwarming story highlights the challenges and opportunities that come with unexpected animal populations. Will the Great Goat Giveaway be a success? Only time will tell. But one thing is certain: Circuitry's future looks a little less bleeding and a lot more barming.
I'm ignored when I try to chat to people. How can I improve my conversation skills? Feeling ignored in conversations can be a real downer, but it doesn't necessarily mean you're a bad conversationalist. There could be a few things at play, and some ways to improve how you connect with others. Sometimes it's about timing. Are you unintentionally interrupting a well-flowing conversation? People get engrossed, and it's easy to miss those subtle cues to jump in. Try waiting for a natural pause, maybe a glance around the group, before offering your thoughts. Similarly, if a group is deeply focused on a specific topic, it might be best to ease in later. You can always strike up a conversation with someone on the fringes who might be more open to a new connection. The environment matters too. Background noise can make it hard to hear or be heard. If possible, find a quieter spot to chat. It allows for better back and forth and shows you're engaged. Now, let's talk about becoming a conversation ninja. Active listening is key. It's not just waiting for your turn to speak, but truly paying attention. Ask questions that show genuine interest in what the other person is saying. Did they mention a recent trip? Ask them about the highlights. This not only makes them feel heard, but also opens doors for further conversation. Being approachable is another superpower. Smile, make eye contact, and ditch the crossed arms or phone browsing posture. Project your voice a little. Confidence is attractive. Finding common ground is also a great way to connect. Maybe you share a love for a certain band, or both went to the same college. Look for those shared interests to spark conversation starters. Speaking of starters, ditch the yes or no questions. Ask open-ended ones that encourage discussion. Instead of, "Did you see that movie?" try, "What did you think of that movie everyone's talking about?" Remember, conversations are a two-way street. Share your own experiences and insights, but be mindful of not dominating the conversation. Let others have their say too. And finally, positivity is infectious. People gravitate towards those who bring good vibes. Avoid negativity and keep the mood light. Improving conversation skills takes practice. Start small with simple introductions and casual talk. Join clubs or groups that share your interests, a built-in conversation starter. Play conversation games with friends. Two truths and a lie, or never have I ever, can be a fun way to loosen up. The key is to be patient and have fun with it. The more you practice, the more comfortable and confident you'll become in conversations, and before you know it, you'll be the one everyone wants to chat with.
Powering up the protein lawnmower, microscopic mowers take to the field. Imagine a microscopic world where blades of grass are formed by protein chains and tiny molecular machines zip around, meticulously trimming them. This isn't science fiction. It's the fascinating realm of protein lawnmowers. These molecular marvels, officially known as trypsin, are a type of enzyme. They bind to specific protein sequences, acting like microscopic shears that snip away at peptide bonds, the molecular links that hold protein chains together. This targeted trimming keeps the protein grass at a precise length, crucial for various cellular processes. But how do these protein lawnmowers get moving? It all boils down to a molecular jiggle. Thermal energy, present in all environments, causes the protein lawnmower to vibrate slightly. This jiggling motion allows the mower to explore its surroundings and eventually encounter a patch of untrimmed protein grass. Once the protein lawnmower bumps into a suitable protein sequence, a fascinating dance begins. The mower binds to the target site, locking into place. This binding triggers a conformational change, a shift in the mower's shape that activates its cutting machinery. The activated mower then goes to work, severing the peptide bond with remarkable precision. Remarkably, these protein lawnmowers aren't just content with a single trim. They can detach, explore further, and keep mowing until they've encountered a specific number of cutting sites or run out of fuel, so to speak. Scientists are particularly interested in this directional movement. Unlike some other molecular motors that move in a straight line, protein lawnmowers seem to exhibit a track-guided motility. Imagine the protein grass as a designated lane, guiding the mower along its path. Researchers are currently exploring this phenomenon, hoping to understand the exact mechanism behind this guided movement. This knowledge could be instrumental in designing new drugs or therapies that target specific protein pathways within cells. So, the next time you look at a lush lawn, remember the microscopic world teeming with protein lawnmowers, diligently maintaining order at a scale invisible to the naked eye. These tiny molecular machines are a testament to the intricate dance of life happening all around us.
The rise of the superbugs. Multicellular bacteria develop immune-like defenses. For a long time, bacteria were seen as simple, single-celled organisms. But recent discoveries have revealed a surprising truth. Some bacteria can form complex, multicellular communities. And these superbugs are developing defenses that eerily resemble our own immune system. Unlike their free-floating cousins, these multicellular bacteria work together for the good of the colony. They share resources, communicate with each other, and even differentiate into specialized cells with unique functions. This newfound complexity presents a significant challenge. These superbugs are much harder to eradicate than their single-celled counterparts. But the most intriguing development is the emergence of defense mechanisms that mimic the human immune system. One such system involves a type of mutation lottery. Within the multicellular colony, some bacteria are programmed to have mutations in their genes. These mutations might make them more susceptible to certain viruses, but they also offer a layer of protection for the entire colony. If a virus attacks, it's likely to target the mutated bacteria first. This sacrificial lamb approach protects the majority of the colony from infection. It's a strategy not unlike how our bodies have a population of white blood cells that can be expendable in the fight against pathogens. Another similarity lies in the concept of diversity is strength. Unlike single-celled bacteria that tend to be genetically identical, these multicellular colonies harbor a degree of genetic variation. This variation allows them to adapt to new threats more quickly. It's a principle mirrored in our own immune systems, where a diverse population of immune cells helps us combat a wide range of pathogens. These discoveries raise a number of questions. How sophisticated are these bacterial defenses? Are they truly analogous to our immune system, or simply a case of convergent evolution? Understanding these mechanisms is crucial for developing new strategies to combat these evolving superbugs. The rise of these immune-wielding bacteria highlights the incredible adaptability of life. It's a sobering reminder that the battle against infectious diseases is a constant arms race. But it's also an opportunity to learn from nature's ingenious solutions and develop new ways to protect ourselves from emerging threats.
Panic pathways. Unveiling the brain's fear circuitry. For those who have ever experienced a panic attack, the sudden surge of overwhelming fear can be debilitating. Recent research has shed light on a new pathway in the brain potentially responsible for these terrifying episodes, offering hope for improved treatments. Scientists at the Salk Institute for Biological Studies have identified a specific circuit within the brain linked to panic disorder. This circuit involves a specialized group of neurons that produce a neuropeptide called PACAP, pituitary adenylate cyclase activating polypeptide. PACAP acts as a chemical messenger, transmitting signals between brain cells. The exciting aspect of this discovery lies in the location of this PACAP pathway. Traditionally, the amygdala, often referred to as the brain's fear center, has been a prime suspect in panic disorders. However, some individuals with damage to the amygdala still experience panic attacks. This new finding points to a separate pathway, outside the amygdala, that might play a critical role. The researchers believe that when triggered by stress or internal imbalances, the PACAP pathway becomes overactive. This surge in PACAP activity disrupts communication within the brain, leading to the cascade of physical and emotional symptoms characteristic of a panic attack, including rapid heart rate, shortness of breath, and feelings of intense dread. This breakthrough holds immense promise for the development of new treatments for panic disorder. Current medications primarily target the brain's serotonin system, but often have limited effectiveness and come with side effects. By focusing on the PACAP pathway, researchers can explore potential drugs or therapies that specifically target this circuit, potentially offering a more targeted and effective approach to managing panic attacks. The discovery of this novel panic pathway is a significant step forward in understanding the complex neurological mechanisms behind these debilitating episodes. It opens doors for researchers to delve deeper into the role of PACAP and identify potential points of intervention. With further investigation, this newfound knowledge could lead to the development of more effective treatments, offering new hope for those struggling with panic disorder.